The James Webb Telescope has essentially revealed the clearest picture of Proxima B in history, uncovering stunning insights into a potentially habitable exoplanet. It invites us on a journey through space to uncover the secrets of Proxima B and determine whether it could be the next Earth. We ought to venture into the vast expanse of space where a mysterious planet exists in the habitable zone of its star Proxima Centauri. This planet is not just any ordinary rock, it is a world of wonders. Proxima B is found a mere 4.2 light-years from us, covered in mysteries and possibilities. Could it be another Earth with oceans and life thriving on its surface? But wait, there's more. Proxima Centauri B isn't alone in that system. Around the red dwarf star it has a companion, Proxima Centauri C. And who knows what other mysteries this star system holds. Maybe there's another companion yet to be discovered. The secrets don't stop there. Proxima Centauri produces roughly the same amount of energy from its star as Earth does from the Sun. Could this truly mean there's water on its surface and perhaps even life? As we explore beyond our solar system, we encounter an entirely new universe of exoplanets, planets that orbit stars other than the Sun. With 200 billion stars in the universe, the possibilities for exoplanets are endless. Some exoplanets even wander freely untethered to any star like travelers in space. Among them, Proxima Centauri B stands out as an especially striking and captivating planet. With a year that lasts only 112 Earth days and a distance from its star much closer than Earth is to the Sun, Proxima B is unique. One side of the planet is constantly bathed in sunlight while the opposite side remains in eternal darkness. Now let's examine Proxima Centauri, the star that Proxima B orbits. Proxima Centauri is part of the Alpha Centauri triple star system, which includes Rigil Kentaurus, also known as Alpha Centauri A and Alpha Centauri B. Together these stars form the closest star system to our solar system. The two stars Rigil Kentaurus and Alpha Centauri B form a binary system known as Alpha Centauri A and B. These G and K-type stars appear as one bright star in the constellation Centaurus and are the third brightest stars in our night sky with a peak luminosity of under 2.7. Proxima Centauri, also called Alpha Centauri C, is a red dwarf or M-type star located 4.2 light-years away. It is the closest star to us, hence its name Proxima, which means nearest in Latin. It was discovered in 1915 by Scottish astronomer Robert Thorburn. Despite being our closest celestial neighbor, Proxima Centauri is not visible to the naked eye. It has an apparent magnitude of 11.13, much fainter than the human eye's limit of 6.5. However, don't let that fool you. Proxima Centauri is still a star worth studying. Red dwarfs like Proxima Centauri are among the most efficient in terms of energy production. They may not produce much energy, but their internal convection processes allow them to shine for trillions of years. Proxima Centauri will likely remain a main sequence star for another 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is still debated. For one, it is a flare star, meaning it has frequent and intense explosions. Its habitable zone is much closer to it than the Sun's, projected to be somewhere in the range of 0.23 to 54 cents. But it's not as habitable as it seems. Proxima B is bombarded by intense ultraviolet radiation from its star, stronger than the radiation we receive from the Sun. This extreme exposure strips away hydrogen, nitrogen, and oxygen from the atmosphere. And that's not all. Just because a planet is in the habitable zone doesn't mean it can support life. Proxima B may not have a stable atmosphere, which is essential for regulating temperature and maintaining a water-friendly surface. Without it, any potential life would be vulnerable to harsh space weather, making survival nearly impossible. So while Proxima B might seem Earth-like at first glance, it is far from being able to support life. Scientists remain cautious as many factors render it inhospitable. However, the mission to reveal the truth about Proxima B continues, and some still hold hope. One tool that has garnered attention is the James Webb Space Telescope. After years of anticipation, it was finally launched in 2021 and is helping determine if there is life on Proxima B. However, as with everything in science, things are never as clear-cut as they seem. Several adjustments were needed to ensure the telescope delivers accurate images. If a planet like Proxima B absorbs light from its star, it can also emit it as infrared light. The James Webb Telescope was specifically designed to detect infrared light. It can capture images of this light from the planet's surface and search for patterns that could confirm the presence of water or an atmosphere. But what if the planet has an atmosphere that's not conducive to life? The presence of an atmosphere doesn't guarantee the presence of life, cautions Ed Turner, an astrophysicist at Princeton University. Proxima B could be like Venus with a thick atmosphere that is significantly denser than Earth's and extreme temperatures that make life impossible. The journey to unravel the mysteries of Proxima B is not without its challenges. While the James Webb Telescope holds promise, there are other factors to consider. With mounting costs, space scientists are under pressure to find new ways to observe planets like Proxima B. But the rewards could be immense. The opportunity to explore the unknown, to uncover the secrets of a distant planet that holds the potential for life, is a pursuit worth chasing. If Proxima B were habitable, might we one day visit? It is the closest exoplanet to us, making it especially intriguing, practically like exploring our own backyard. Even more exciting, it is roughly the same size as Earth, and its position in the habitable zone suggests it could have conditions suitable for life. However, reaching Proxima B is no easy task. It would take 75,000 years for a spacecraft like Voyager 2 to reach the Proxima Centauri system. Nonetheless, a proposed solution is solar sails, ultrathin sails that use solar pressure to propel spacecraft, eliminating the need for traditional fuel. This cutting-edge technology could revolutionize our ability to explore exoplanets like Proxima B. Yet there are limitations. Even if the planet has an atmosphere, it might not be habitable. It could be like Venus, hot and inhospitable. Despite these challenges, discoveries continue. The James Webb Telescope recently found the first definitive evidence of carbon dioxide in the atmosphere of an exoplanet outside our solar system. This breakthrough provides crucial insights into planetary composition and formation, bringing us one step closer to understanding distant worlds. As we continue our search for extraterrestrial life, the James Webb Space Telescope is unveiling the secrets of the universe one discovery at a time. The possibilities are endless, and the next great revelation may be just around the corner. The James Webb Space Telescope is just the beginning. As technology advances, scientists are developing even more sophisticated tools to probe the mysteries of exoplanets. One of the most promising future missions is NASA's Nancy Grace Roman Space Telescope, set to launch later this decade. This telescope will conduct a large-scale survey of exoplanets using advanced optics and cutting-edge coronagraphs which block out starlight to directly image distant planets. Additionally, the European Space Agency (ESA) is working on Plato planetary transits and oscillations of stars, a mission designed to discover and study Earth-like planets around sun-like stars. Unlike previous missions that primarily identified gas giants, Plato will focus on rocky planets in habitable zones, worlds that could harbor liquid water and potentially life. Even more ambitious is the proposed LUVOIR Large UV/Optical/IR Surveyor Telescope, which could launch in the 2040s. LUVOIR would have an enormous mirror capable of directly imaging Earth-sized exoplanets, analyzing their atmospheres for biosignatures like oxygen, methane, and water vapor. One of the most exciting aspects of exoplanet research is the search for biosignatures, chemical or physical indicators of life. While Earth's atmosphere is rich in oxygen, which is produced by photosynthetic life, other planets may have different markers. For example, if a distant world exhibits any of these markers, it would be a strong candidate for further study. While the discovery of alien life remains speculative, each new finding brings us closer to answering one of humanity's greatest questions: are we alone in the universe? If we were to find a truly habitable exoplanet, the next challenge would be reaching it. As mentioned earlier, solar sails could be one of the first steps toward interstellar travel. One initiative, Breakthrough Starshot, aims to send tiny high-speed spacecraft to Alpha Centauri within the next few decades. These spacecraft, propelled by powerful laser beams, could reach speeds of 20% the speed of light, allowing them to reach Proxima Centauri in just 20 years instead of tens of thousands. Another potential technology is nuclear fusion propulsion, which could dramatically cut travel times. The concept involves harnessing nuclear reactions similar to those in the Sun to generate thrust, enabling spacecraft to travel at a significant fraction of light speed. Beyond that, scientists are even considering warp drives, a theoretical concept inspired by Einstein's general relativity. If feasible, a warp drive could bend spacetime, allowing a spacecraft to jump across vast cosmic distances almost instantly. While this remains firmly in the realm of science fiction, breakthroughs in quantum physics and space-time mechanics could one day make it possible. With thousands of exoplanets already discovered and more being found every day, we are on the brink of a new era in space exploration. The next few decades will see more powerful telescopes, new missions to study alien worlds, and the first steps toward interstellar travel. Perhaps one day humanity will set foot on a distant exoplanet, gazing up at an alien sky filled with unfamiliar stars. Until then, our search continues, one telescope, one discovery, and one breakthrough at a time.